So we've looked a lot at creating transactions and sending transactions, but that's not always the end of the story. There are additional ways we can control our Bitcoin transactions after they've been sent. And typically these come through the mechanisms of replace by fee or RBF and CPFP, which is child pays for parent. And these allow you to control your transaction after they've been sent. You might want to improve the efficiency of your transaction by batching different inputs together, or your transaction might just get stuck because a miner's not incentivized to include it in a block due to a low transaction fee. And this mechanism allows us to understand like some of the true power of Bitcoin. And so over the next couple of videos, we'll be deciding whether or not RBF or CPFP are useful in our transactions, and how to create a replacement transaction using RBF, replaced by fee, and also how to create new transactions using CPFP. It's a bit of a mouthful, or child pays for parent. And some of the concepts that will support us in understanding some of these concepts are stuff like the mempool and understanding what that is and what role that plays, especially in mining, and then understanding the difference between RBF and CPFP, and the power of RBF as well. So typically, I guess in this situation, when we want to be able to identify when a transaction gets stuck, and what that typically means is that a transaction can get stuck for a number of reasons. It can get stuck perhaps because we haven't provided a sufficient transaction fee, or there might be just like a network error or some type of software glitch. So if we want to find out if our transaction is stuck, from the command line, we can run commands that we should be quite familiar with now. So if we list our transactions, and list transactions, this returns us a list of all our transactions. So if I take let's have a look. If I take the transaction ID of just this first one, I'll copy that. And if we want to get a bit more granular information about that specific transaction, we can just run the get transaction command. So Bitcoin CLI, we'll use the name flag to make it a bit more easy to understand. Get transaction and pass in the transaction ID. Okay, so this gives us some information about our transactions, where it was sent, how much was sent, how many confirmations, a transaction ID, etc., etc. And we would know if this transaction was having any issues, or there was something wrong with it, because the confirmations for the transaction would equal 0. So let's say you've sent a transaction and after a couple of hours you're not receiving any confirmations. You can probably guess that there's something not quite right about this transaction, or it's stuck, or the miners haven't been incentivized enough to include it in a block. But it's not something you should worry about, and it's not you won't lose any funds or any Bitcoin or anything like that. But it is important to identify some of the things that can allow you to essentially make sure the transaction maybe goes through at a later date. And so now I'm gonna just mention the mempool. I mentioned this term earlier in the video, and the mempool, or the memory pool, is basically a pool of all of the unconfirmed transactions at a Bitcoin node. So transactions are received at a Bitcoin node via like the peer-to-peer network that Bitcoin has, and each Bitcoin node can have a slightly different set of transactions in its mempool, because different transactions might have been propagated to different nodes throughout the network. And so when miners when they create blocks, they'll use the transactions that are part of the mempool, and then when a block is verified, all the miners remove the transactions that are contained from their pools, um, and then they will receive transactions from the network going forward, different transactions from the network going forward. Um, and a lot of mining pools have their own like mechanisms for managing that whole process. But we won't go into that in this video. Um, so the list of all unconfirmed transactions might not match any individual machine's mempool, but it should mostly be like a superset of the same thing pretty much. And so once you've identified that your transaction is stuck or it hasn't reached its destination, what are some of the things you can do to remedy the situation? So you can wait until it clears. So if you've sent a transaction with a low or a medium fee, it should eventually go through. Because if we have a look at Bitcoin fees, if I head over to the browser quickly, and this just tells me like what the average transaction fee per byte is at the minute. So at the minute, we have the fastest and cheapest transaction fee is currently 8 satoshis per byte, shown in green at the top here, and then for the median transaction size of 202 bytes, this results in a fee of 1,616 satoshis. So at the minute, 8 satoshis is the fastest and cheapest way to send Bitcoin. And this bit is quite important as well. So the delay shown here is the predicted number of blocks that transactions will take to confirm. If transactions are predicted to have a delay between 1 and 3 blocks, there is a 90% chance that they will be confirmed within that range, around 10 to 30 minutes. So you can just wait for it to clear, and over time, given some time, it will appear in a block, potentially 1 to 3 blocks in the future. Alternatively, you can wait until it expires. So if you did send a transaction with no fee, and you didn't send it with a fee, you shouldn't worry too much. Your coins won't be lost, and as long as the wallet you sent the Bitcoin from doesn't purposefully resend unconfirmed transactions, it should clear from the mempool within a few days, and then you can try again. And then the last two things that you can decide to do is take things into your own hands a bit more and use RBF as the sender of the transaction. So RBF is that replaced by a fee mechanism. And if you're a sender of the transaction and your wallet has opted in for replaced by a fee, then you can try again. So you can try and send the transaction again, but this time attach a slightly higher transaction fee to it. And hopefully that will mean it will get into the next block or some blocks after at slightly faster rate. And then the last thing you can do is as the receiver or the person you send the Bitcoin to, they can do a child pays for parent transaction basically. And this is not really, I guess it's not really a feature. This is more of a concept, and it just uses usual transaction. But what it does, if you're the receiver of the transaction and you use a child pays for parent transaction, it basically means you're using that unconfirmed transaction as an input in a new transaction. So basically you use this unconfirmed transaction, you create a change address, and that change address is then the recipient for the transaction that was initially stuck. But we'll look at those in the next couple of videos, as I think they'll make a bit more sense if we go into a few examples. So Just to recap, this is pretty much about us trying just to understand and watching for any transactions that might get stuck, and using our commands like get transaction to investigate what is happening with our transactions, and looking at the confirmations will tell us a lot about the state of our transaction and if we need to do anything more going forward. So I hope that makes sense, and I will see you in the next one. Peace.